Alright, today we're talking about trigonometric ratios and right triangles. Trigonometric ratio is the ratio of the lengths of the sides of a right triangle related to the acute angles. So the three most common ratios are sine, cosine, and tangent. Those are the ones we're going to be focusing on in this lesson. So here's a right triangle, and the sides have been labeled x, y, and z. The sine of angle A, here's angle A, can be abbreviated like this. When you see this, please make sure you're saying sine and not sin. That's the abbreviation. Sine of A is equal to the opposite side over the hypotenuse. Okay, well, the hypotenuse doesn't change. It's always the side opposite the right angle. It's the longest side of the right triangle, so Z is the hypotenuse. Now, which side is opposite and which side is adjacent, as we'll talk about later, is determined based on the angle. So if we're doing angle A, here's angle A, the side opposite angle A is x. So this is the opposite side. So for the sine of angle A, it's opposite over hypotenuse. Opposite is x, the hypotenuse is z. Cosine is always adjacent over hypotenuse. So if I'm doing cosine of angle A, the adjacent side, well, obviously there's only three sides to a triangle. I've already labeled this opposite and this hypotenuse. That means this side over here would have to be the adjacent side. Adjacent is when they're adjoined, they're connected, touching side by side, and it can't be this one because that's the hypotenuse. So it's this side right here is the adjacent. So when it says adjacent side over hypotenuse, adjacent side is y, hypotenuse is z. So the cosine of angle A would be y over z. Okay, tangent of A. Tangent is opposite side over adjacent side. Opposite angle A is x, adjacent is y. So that would be x over y. And again, these are the full words over here, and these are the abbreviations. Again, please make sure you're not saying cos and tan. It's cosine and tangent. These are just the abbreviations. Alright, now we're going to change to angle B now. Now how that affects things, on a right triangle, this is always the hypotenuse. That's not going to change. But now if I move over here to angle B, what side is opposite angle B? Y is. So when I move over to angle B, this side becomes the opposite, and the x becomes the adjacent. It's the side that's part of that angle that's not the hypotenuse. That's called the adjacent. So for the sine of angle B, opposite over hypotenuse, opposite angle B is y, hypotenuse is z. Cosine of B is adjacent over hypotenuse. Well, for angle B, the adjacent side is x, hypotenuse is z. And the last one here, tangent of angle B is opposite over adjacent. So again, from angle B, opposite is y, adjacent is x. So opposite over adjacent would be y over x. So you see how the opposite and adjacent side switches depending on which angle you're using. The hypotenuse is always the same. Here is your abbreviation or thing to memorize so that you can memorize all these ratios. SOHCAHTOA, SOHCAHTOA. And what this means is that sine of an angle is equal to the opposite over the hypotenuse. Cosine of an angle is equal to the adjacent over the hypotenuse. And tangent of an angle is equal to the opposite over the adjacent. So if you can just memorize SOHCAHTOA, then you can remember all of these ratios without having to try to memorize the whole thing in long form there. SOHCAHTOA, SOHCAHTOA. And I heard some goofy story about a Indian princess that saves a whole hunting party from a burning fire, and she had to run over the embers, and she saved them all. Her feet were burned, and they had to soak her toes in the water to make them better, and so they named her SOHCAHTOA. So just something goofy and silly to say so that it can help sink in. SOHCAHTOA. SOHCAHTOA. Alright, so on example 1, let's find sine of A, cosine of A, tangent of A, sine of B, cosine of B, and tangent of B. Express each ratio as a fraction. So we're just setting them up. We're not really solving for anything. So if I want to find the sine of angle A, let's remember SOHCAHTOA. I'm going to write it up here for us to remember. SOHCAHTOA. Sine is always opposite over hypotenuse. So if I'm doing A, here's A. What's opposite angle A? The 5 is. What's the hypotenuse? It's opposite over hypotenuse. What's the hypotenuse of this triangle? Opposite the right angle, the longest side here is the hypotenuse, so the hypotenuse is 13. So sine of angle A would be 5 over 13. If I do cosine of A, cosine is adjacent over hypotenuse. Well, adjacent to angle A would be this 12 here. It's the only side left after I've already labeled opposite and hypotenuse. So adjacent over hypotenuse would be 12 over 13. And then tangent of angle A is opposite over adjacent. So opposite would be 5, adjacent would be 12. So there's all of them dealing with angle A. Now we're switching to angle B. Now if it helps you to have them all pre-labeled before you get started, let's do that. If I switch over here to angle B, what side is opposite angle B? That would be the 12. So this side is now the opposite. This is always the hypotenuse. That's not going to change no matter which angle you're using. We never use the right angle. We always use one of the acute angles. If you use the right angle, it's going to be undefined. So the side, if this is the hypotenuse, this is the opposite, that makes this the adjacent. Okay, so if I'm doing sine of B, again, sine is opposite over hypotenuse, so opposite angle B is 12, hypotenuse is 13, so that would be 12 over 13. Cosine of B, cosine is adjacent over hypotenuse, so from B, adjacent is 5, hypotenuse is 13. And last, tangent of B, opposite over adjacent. Opposite over adjacent. 12 over 5. So there's all of our tangent ratios expressed as a fraction. Alright, same thing down here. Let's go ahead and label everything. Opposite the right angle is always the hypotenuse. Let's see what angle I'm doing first. Angle S. So from angle S, the opposite side would be the 3. The adjacent would be the 4. So sine of S, sine is opposite over hypotenuse. Opposite over hypotenuse, 3 over 5. Cosine of S, adjacent over hypotenuse. Adjacent over hypotenuse. As long as I've got them labeled and I'm staying with the same angle, it's pretty easy to do this. Tangent is opposite over adjacent. Opposite over adjacent. The one thing I need to remember is when I switch to a different angle, I got to adjust my sides and what they're labeled as. So now I'm switching to angle E. So now, if I'm now switching to angle E, what's opposite angle E? This is opposite angle E. And so that makes this the adjacent. When you switch which acute angle you're using, it just switches which side is opposite and which side is adjacent. Those will switch every time. The hypotenuse stays the same. Sine is opposite over hypotenuse. Opposite over hypotenuse. 4 over 5. Cosine, adjacent over hypotenuse. Adjacent over hypotenuse. And then tangent, opposite over adjacent. Opposite over adjacent. Alright, something we're not going to do a whole lot of, but I want you to know how to do it, is to use a trigonometric table to evaluate expressions involving these trig ratios. Back before they had calculators, they had to use these tables to find everything, so I'm just going to show you how to do that real quick. We want to find what cosine of 41 degrees would be. So here is a trig table. So notice that they give you the measure of the angle, what the sine of the angle would be, what the cosine of the angle is, and what the tangent of the angle is, right? We want cosine of 41 degrees. So cosine is this middle column right here, and I want to come down to where it's 41 degrees. So here's the angle that's 41 degrees. This is cosine. So I'm going to write down 0.7547. 0.7547. All right, let's try sine of 78 degrees. Okay, well this one only goes to 45, so I got to go to the other side where it repeats the same stuff again. Again, you got the angle, sine, cosine, and tangent of the angle. And we wanted what? We wanted sine of 78. So sine is this first column, 78 degrees, right here. So 0.9781. So simple enough to just find it on the table. 0.9781. Alright, on to the next page. So far it's just been telling us what ratios to set up. Let's start actually using this information to find missing sides of right triangles. So, for example, right here on this right triangle, this is the hypotenuse. I'm going to label that. I need to pick an angle. I have both of my acute angles here. I need to use one of them, and it doesn't really matter which one. Let's say I'm going to use the 21 degree angle. If I want to solve for x, x is opposite the angle. Notice I was not given the adjacent side, and it's not a variable that I'm supposed to find. So the adjacent side is really irrelevant to me right now. So I have the hypotenuse and I want to find the opposite. So I want to use the trig ratio that involves the opposite and the hypotenuse. Well, let's remember, SOHCAHTOA, which one of our trig ratios, sine, cosine, or tangent, uses opposite and hypotenuse? You should see opposite and hypotenuse right here for sine. So because of the particular size I'm using, the ones I have and the ones I want to find, I want to use sine. So I'm doing sine of the 21 degree angle is equal to the opposite over the hypotenuse. Sine of the angle is equal to the opposite over the hypotenuse. So that's how we set up the equation, and then we just have to solve for x. So right here, x is being divided by 9, so if I want x by itself, I would have to multiply by 9, and that would give me x all by itself. If I do an operation on one side, I got to do it on the other side. So what I'm going to type into the calculator is 9 times the sine of 21. 9 times the sine of 21. And very important, make sure that your calculator is in degrees, because if your calculator is in radians or some other form of measuring angles, then you're going to get the wrong answer. So make sure your calculator is set for degrees. And let's just round to the nearest hundredth on everything on this assignment. So this would be approximately 3.23. Now, remember earlier I just chose to use the 21 degree angle. Now, I've done the entire problem. There's no need for me to have to do anything else, but since I'm doing notes here and just showing you how things work, let's do it a different way. Let's say earlier I chose the 69 degree angle. Well, if I chose the 69 degree angle, then this is no longer the opposite side. This side is opposite. This is the adjacent side. Remember, it switches if you switch which angle you're using. If I'm doing that, then I've been given the hypotenuse, and now I'm looking for the adjacent. So adjacent and hypotenuse. Which one of the three trig ratios uses adjacent and hypotenuse? Adjacent and hypotenuse is cosine. So another way I could solve the same problem is to set it up doing cosine of the 69 degree angle is equal to the adjacent over the hypotenuse. Again, if I'm solving for x, it's being divided by 9, so I'd have to multiply by 9. If I do it on one side, I got to do it on the other side. Type this in your calculator, and you should notice you get the exact same thing. 9 times the cosine of 69, again, you would get 3.23. So there are two different ways you could have solved the same problem. You don't need to do both, but either one of those would be acceptable. Let's try B. Okay, pick an angle. So I'm just going to pick this 37-degree angle. Let's label the sides. I always start by labeling the hypotenuse, or most commonly start by labeling the hypotenuse. Then the side opposite the 37 degrees is over here. I don't have that side, and I haven't been asked to find that side. This side would be the adjacent side. So I've been given the hypotenuse. I want to find the adjacent. So again, I need a trig ratio that has these two in it, adjacent and hypotenuse. So I go back up to SOHCAHTOA, adjacent and hypotenuse. I know I want to use cosine. So cosine of 37 is equal to the adjacent over the hypotenuse. So there's the equation. Solve for x. It's being divided by 13, so I multiply by 13. Do it on one side, then I got to do it on the other side to keep the equation good. So I'm typing in the calculator 13 times the cosine of 37. And I should get approximately 10.38. Again, we're just going to round to nearest hundredth on all the problems on this assignment. All right, let's look at C. Now on C, we want to find x and y. And they only gave us one of the angles. Now technically, we could find the other angle. Remember, the three angles in a triangle add up to 180? So it's simple enough to find this angle, but that's extra work I don't have to do. So I'm just going to use this angle they've already given me. I'm going to label the sides. So the hypotenuse is the 8 because it's opposite the right angle. The side opposite the 36-degree angle is x, and that would make y the adjacent side. All right, let's say I'm solving for x. So I need to use the side I've already been given, and I need to use the x. Can't solve for x unless it's part of the equation. And I don't want to put y in the equation because I don't want two variables in the same equation. I can only solve for one variable at a time. So I'm going to act like this isn't even here right now. I need a trig function that has opposite and hypotenuse. I have the hypotenuse. I want to find the opposite. I need the trig ratio that has those two. So if you're remembering your SOHCAHTOA, sine is opposite over hypotenuse. So to solve for x, I'm using sine. So sine of 36 is equal to the opposite over the hypotenuse. So there's the equation. And then solving for x. X is being divided by 8, so I'm going to multiply by 8. Again, if I do it on one side, I got to do it on the other side. So 8 times sine of 36, and you should get approximately 4.70. So that was solving for x. Let's solve for y. So I have the hypotenuse. Now technically I have the opposite now, but it's a rounded number. It's not exact. And every time you use a rounded number in a problem, you get just a little bit farther away from the actual answer. So I prefer to use exact numbers whenever possible. So I'm just going to act like I don't have that right now. I have the hypotenuse. This time I'm solving for y, so I want to find the adjacent. So adjacent and hypotenuse, I need to use cosine. SOHCAHTOA. Cosine adjacent over hypotenuse. All right, so cosine of 36, adjacent was y, hypotenuse is 8. So there's the equation you should have set up. Y is being divided by 8, so I multiply by 8. If I do it on one side, I got to do it on the other side. So 8 times the cosine of 36 should get approximately 6.47. Okay, let's try it again on D. Same thing. Here's the angle they've given me. I could find this one, but don't need to. Label the sides. I've got a hypotenuse here. The side opposite the 50-degree angle is the x, and that makes the y the adjacent. So I'm solving for x. Again, I don't want to use y. So I have the hypotenuse. I'm looking for the opposite, so I'm using sine. Sine of the angle, which is 50 degrees, is equal to the opposite over the hypotenuse. So there's the equation. Solve for x. So I'm going to multiply by 11 to get rid of that. So 11 times the sine of 50 is approximately 8.43. Okay, let's solve for y. So let's act like the x is not there. I've been given the hypotenuse. I want to find the y, which is the adjacent. So adjacent and hypotenuse, that's when we use cosine. So cosine of 50 is equal to the adjacent over the hypotenuse. Multiply by 11 to get y by itself. Do it on the other side to keep the equation good. 11 times the cosine of 50 is 7.07, approximately. Alright, example 5. So again, let's label the sides. I got this 30-degree angle here I'm going to use. From the right angle over, this is the hypotenuse. Opposite the 30-degree angle is x, and then that makes this side the adjacent. Alright, so if I'm solving for x, I've been given the adjacent side. X is what I'm trying to find. That's the opposite side. I'm ignoring y because I haven't been given it, and I'm not trying to find it yet. I'm focusing on x right now. So I need a trig ratio with opposite and adjacent. So if you remember, SOHCAHTOA, which one has opposite and adjacent? Opposite and adjacent is tangent. We haven't used tangent on our examples yet. So tangent of 30 is equal to the opposite over the adjacent. Opposite is x, adjacent is 6. So there's our equation. We just solved for x. It's being divided by 6, so we multiply by 6. Do it on one side, do it on the other side. So I'm doing 6 times the tangent of 30. Should get approximately 3.46. Okay, let's solve for y. So again, I already have the adjacent. Now I'm looking for y, which is the hypotenuse. So if I'm doing adjacent and hypotenuse, that would be cosine. So I'm setting that up. Cosine of the 30-degree angle is equal to the adjacent, which is 6, over the hypotenuse, which is y. So there's the equation. And then we're solving. Now this is the first time we've had an example where the variable is in the denominator. You can't solve for a variable while it's in the denominator. So the first thing is to get it out of the denominator. So I'm going to multiply by y. That'll get it out of there. If I do it on one side, I got to do it on the other side. So I'll multiply by y over here. So we got y times the cosine of 30. Well, we're not good until the y is all by itself. Right now, y is being multiplied by cosine of 30. So if I want to get y by itself, I'm going to divide by the cosine of 30. If y is multiplied and divided by the same number, then those are just opposite operations that will cancel each other out. Now if you do it on one side, you got to do it on the other side. So I am now doing 6 divided by the cosine of 30. 6 divided by the cosine of 30 is approximately 6.93. 6.93. Alright, let's look at our last example. And we got several things we're going to solve for here, but it's the last one. Alright, let's see what we got going on here. First off, we got a linear pair right here. And so they're supplementary. They have to add up to 180. So if this is 90, this is 90. So here's a right triangle, and here's a right triangle. Let's see what we can figure out. Okay, if I focus on this right triangle and ignore the other one, then I want to find out what x is. I've been given 8. So let's label the sides. Again, let's ignore everything that's over here. So on this right triangle, the hypotenuse is the 8. And if I'm using this 45-degree angle here, then x would be the adjacent side. So let's find x now. If I'm using adjacent and hypotenuse, that would need to be cosine. So I'm going to set that up. Cosine of 45 is equal to the adjacent x over the hypotenuse 8. So there's the equation. Solve for x. X is being divided by 8, so I'll multiply by 8. Do that on both sides. So I'm typing in the calculator 8 times the cosine of 45, and I should get 5.66 approximately. Okay, let's solve for y. Now y is a part of both triangles, but I don't know any of the sides on this triangle yet. I know sides on this triangle. So from that 45-degree angle, y is the opposite side. So if I want to solve for y, I've already been given the hypotenuse. I'm trying to find y, which is the opposite side. So opposite and hypotenuse uses sine. So I'm doing sine of 45 equals the opposite, y, over the hypotenuse, 8. So there's the equation to solve for y. So y is being divided by 8, so I multiply by 8. If you do it on one side, do it on the other. So I'm doing 8 times the sine of 45. And we should get approximately 5.66 again. Alright, now y and z are both, or excuse me, w and z are both a part of this triangle. And we didn't have any sides yet. So while I prefer to use exact numbers whenever possible, the only side that I now know for this is the y that we just found out was approximately 5.66. We're going to need to use that so we can find out what z and w are. So let's figure out what w is. So now switching gears to a new triangle. Here's the right angle. That makes z the hypotenuse. If I'm using this 30-degree angle, then y is the opposite, and w would be the adjacent. So if I want to find out what w is, I already have the opposite side, because we just found it a minute ago, and w is the adjacent side. So I'm ignoring the hypotenuse. I'm ignoring z for right now. So opposite and adjacent. If I'm using opposite and adjacent, that would be tangent. Tangent is opposite over adjacent. So I'm setting up this equation. Tangent of the 30-degree angle is equal to the opposite over the adjacent. And the adjacent is w. So we have our equation set up now. And our variable's in the denominator. So remember, we got a two-step process. First step is to get the variable out of the denominator by multiplying by that variable. And then we want to get the variable by itself. W is being multiplied by the tangent of 30, so I do the opposite and I divide by the tangent of 30. If I divide by the tangent of 30 on one side, got to divide by the tangent of 30 on the other side. So this is what I'm typing in the calculator. 5.66 divided by the tangent of 30. Now, your answer might vary depending on what you typed in the calculator. I had the previous answer for y already in my calculator. If I take that and put that in, divided by the tangent of 30, I get 9.7979589, whatever. If I type in 5.66, it looks a little different, 9.80340757. It looks a little different. However, if we round into the nearest hundredth, it's going to come out the same for both of them. But that might not always be the case. So, very important that you're showing me your work, and so I have a decent idea of why you got what you got. But I will accept it if you're using the rounded one. Okay, last one, z. We need to find z. Now, technically, I could use either one of these because we have both. Neither one of them are perfect, but I'm just going to stick with using the 5.66. So we're going to ignore w now. We have the opposite side. We want to find the hypotenuse, z. So opposite and hypotenuse is using sine. So we're going to set it up. Sine of 30 is equal to the opposite, which was the 5.66, over the hypotenuse, which is z. So here's our equation for solving for z. Again, the variable's in the denominator. First step, multiply by that variable to get it out. We don't want it in the denominator. Do it on one side, then you got to do it on the other side. And then z is being multiplied by the sine of 30, so if I'm going to get it by itself, I have to do the opposite operation and divide by the sine of 30. So in the calculator, I'm doing 5.66 divided by the sine of 30, and that gives me approximately 11.32. So there's your introduction to sine, cosine, and tangent, your introduction to trig.